In the last standard of this unit, we will be dealing with the average rate of change. The standard is FIF6. Calculate and interpret the average rate of change of a function. Rate of change. Now, this should be a review from last year's standards that deals with slope. A rate of change shows how one quantity changes relative to another quantity. To calculate the average rate of change between two ordered pairs x1, y1, and x2, y2, use the following formula. As you can tell, this is the same formula you used in the 8th grade standards to find the average rate of change or slope. Recall that for a linear function, the average rate of change is the slope, which is constant. For an exponential function, the average rate of change is not constant. Again, linear function, constant rate of change. Exponential function, not constant. An exponential function is a graph that is a curve. An exponential growth function is always increasing, while an exponential decay function is always decreasing. The value of an exponential function grows by equal factors over equal intervals. If the factor by which the function changes is greater than 1, then the function represents exponential growth. If the factor is less than 1, then the function represents exponential decay. Example 1. Find and describe the average rate of change for 4 consecutive pairs of values in the table. Okay, so we're going to look at f of x is 16 to f of x is 4. Now, x1, y1, x2, y2. 4 minus 16 divided by negative 1 minus negative 2. Let's pop that in the calculator. 4 minus 16, and I get negative 12 divided by negative 1 minus negative 2, and I get positive 1. So that's a negative 12 over 1 rate of change. Now let's look at 64 to 1. x1, y1, x2, y2. 1 minus 64 divided by 0 minus negative 3. 1 minus 64, you get negative 63, divided by 0 minus negative 3, which is positive 3. Simplify that, and you get negative 21. As you can tell, they are not a constant rate of change, so that is an exponential function. Now, last example. Compare the rate of change. Actually, this is the last example. The graph below represents 2 to the power of x. Find the rate of change from 0, 1 to 1, 2. 0, 1, 1, 2. x1, y1, x2, y2. 2 minus 1, 1 minus 0. I get 1 over 1. So it has a slope of 1. Rate of change is 1. Now let's look at the rate of change from 0, 1 to 3, 8. 0, 1, 3, 8. x1, y1, x2, y2. 8 minus 1, 3 minus 0, and I get 7 over 3. As you can tell, it is a non-linear function, so the rate of change will change from coordinate to coordinate.